Good morning, good afternoon, and good evening. Welcome to the webinar on Greening the Chemical Industry, International Perspective and Insights. My name is Lydia Voitel. I am the project lead for International Network of Energy Transition Think Tanks, or INET, and I have the pleasure to welcome you to this webinar, which time-wise cuts through at least five time zones, and is hosted by the Green Energy Strategy Institute, or GESI, in Seoul, South Korea. This event explores the decarbonization of the chemical industry within national contexts and features insights from experts all around the world. We will hear from Agora Industry in Germany, Institute for Essential Services Reform in Indonesia, and Agora Energy Transition China in China, as well as the SENAI National Service for Industrial Training, or SENAI, from Brazil, and of course, the Green Energy Strategy Institute in South Korea. During today's event, these experts will discuss the challenges and alternatives for decarbonizing the chemical industry in the 5 countries, and that is with the aim to facilitate international cooperation and in-depth dialogues, aligning strategies that expedite the global energy transition within the chemical sector. This is meant to significantly contribute to the global efforts to achieve carbon neutrality. I hope our attendees have already joined us or are slowly joining, but while they do, I will outline the plan for today's event. And this webinar, which is planned for 2 hours, consists of 2 parts. In the first one, after a framing introduction presented by Pil-Seok Kwon from GESI, we will hear presentations covering the circumstances surrounding the decarbonization of chemical industries in 5 countries, as well as find out about the challenges and solutions proposed by our speakers to address those challenges. The second part embraces a more interactive setting, and our speakers will engage in a moderated panel discussion followed by a Q&A session. This brings me to the part where I inform you that we will use the chat box below to answer any questions or comments of technical nature, such as bad sound quality or questions on where I can find the presentations. And these will be overseen by Hyunji. Hyunji, say hello to us.
Hello.
Thank you for being with us, Vicky. Thank you for taking care of all the technical issues with today's event. And on the other hand, you'll see that in the bottom of the screen, there's also a Q&A box, and this can be used throughout the event, and you are warmly invited to ask questions of substance in there. Some of these questions will be answered throughout the session, and we will also try to address the ones left in the live Q&A session at the end of the event. I would also like to inform you that this webinar is being recorded and that both the presentations and the recording will be available after the event. Now, without much ado, I would like to hand over to Pil-Seok Kwon to provide us with the overview on the subject of today's event. And to introduce Pil-Seok, I would like to say that he's the director of the Green Energy Strategy Institute, and his research interests lie mainly in energy system modeling and scenario analysis, with a primary focus on the large-scale integration of variable renewable energy resources into the electric grid of the future. Using energy system modeling, he explores renewable energy scenarios at both the municipal and national levels and conducts economic feasibility studies for various energy projects. Pil-Seok, you have the screen, please.
Thank you. Thank you for the introduction, Lydia. So welcome to our seminar, Greening the Chemical Industry, International Perspective and Insights. It's a pleasure to host experts and professionals from Brazil, Germany, Indonesia, China, and Korea. Today, we embark on a crucial journey toward a sustainable and carbon net neutral future. The chemical industry is pivotal to our economies, but faces significant challenges. which is to reduce its carbon footprint. It is the largest industrial energy consumer and the third largest industry subsector in terms of direct CO2 emissions. This webinar offers an excellent opportunity to exchange innovative ideas, breakthroughs, and the strategies from across the globe. The decarbonization of the chemical industry is a very complex issue, often overlooked by us, Energy Transition Think Tank, due to the intricacies involved and the difficulty in finding zero-emission alternatives. While this sector has been expanding these days, its carbon emissions have not been adequately addressed. It's time we focus on decarbonizing this industry. Each country's chemical industry has its own unique products and highly depends on the trading raw materials. This will not only emphasize the need for country-specific decarbonization plan, but also underscore the importance of the international dialogue. Therefore, it is important that each country share unique perspectives shaped by their distinct experiences. As we start to comprehend the way to reduce the carbon intensity of the chemical industry, today's discussion will revolve around the current state of the industry in our respective countries, identifying challenges and exploring collaborative solutions. Our collective insights as a member of energy transition think tanks are crucial to create effective global strategies. I urge you all to share your valuable insights and work together for a more sustainable future for the chemical industry. Thank you. I would like to hand in my mic to the Lydia again. Thank you.
Yes, thank you very much. Indeed, I will be getting the mic once in a while to introduce new speakers and tell you where in the event we are. So thank you, Philstock. As we have heard, chemical industry decarbonization lies at the heart of the efforts which need to be made to reach climate neutrality. And we do think that think tanks have an important role to play in this process. And I am very glad to confirm that we have a fantastic host of experts who can provide us with more information on how this can be achieved. And now I would like to introduce our speakers in the order of their presentations, and I would like to ask them to maybe wave and say hello to the audience as I introduce them. We start with Paul Munich, who works as project manager climate neutral industry at Agora Industry in Berlin since April 2021. His main field of expertise are transformation of chemical industry, electrification of process heat, and industrial policy in Germany. Hello, Paul. His presentation will be followed by insights from Indonesia and delivered by Farisha Hidayati, who currently holds the position of Industrial Decarbonization Project Coordinator at the Institute for Essential Services Reform, or IESR, in Indonesia. In addition to her research roles, she has also extensive experience working with leading electrical and electronic manufacturing companies in Indonesia as a manufacturing engineer designer. Good afternoon or good evening to you, Farisha.
Good afternoon, Lydia from Indonesia.
The third presentation will come from Isadora Wang, who is the Senior Advisor China Industry at Agora Energy Transition China. She is responsible for Agora's work on industrial decarbonization in China, covering sectors such as iron and steel, cement, chemicals, and sector coupling based on a renewable hydrogen. Good afternoon to you, Isadora.
Good afternoon, Lydia. Thank you for the introduction.
And after that, we will move to Brazil to hear from Leonardo Teixeira, who is a chemical engineer working as the coordinator of the competitive intelligence area of Senai Innovation Institute for Biosynthetic and Fibers, working with the development of roadmaps, sustainability assessments, and intellectual property management. as well as knowledge management. Good very morning to you, Leonardo. I know it's horribly early. It's 4 a.m., is it?
Hello, everyone. Yes, thank you very much for the invitation. It's a pleasure to be here.
Thank you very much for your engagement and getting up so early. And the last presentation will come from the host of today's event and will be delivered by Boram Kim, who is a senior researcher at the Green Energy Strategy Institute. Her primary research areas encompass life cycle analysis, socioeconomic impacts of renewable energy systems, and the decarbonization of the industrial sector. And now, having introduced all of our speakers, I would like to ask Paul from Agora Industry to take the screen away from me and to update our knowledge with insights from Germany and the European Union. Paul, you have the screen.
Thank you very much, Lydia. It's a pleasure to be here and to steal the screen from you. Thank you also for the introduction. Yeah, my name is Paul Munich, and I'm going to explain a little bit on our recent work on transforming the chemical industry in Germany. But since Germany is very much embedded into a European chemical industry, we'll also touch upon this a little bit. We have also just published a study this summer called Chemicals in Transition. The study is available in German and in English language and available on our website for free download. So let's start with looking at the global markets of chemicals. And the European Union is still the second largest chemical producer globally. And we at Agora Industry, we believe that Europe is actually well set to be a driving force for the global transformation of chemicals, mainly due to three key reasons. First of all, Europe has a very long history with regulating chemicals, and we're also pretty good at process optimization. And together, this regulation and process optimization have already reduced greenhouse gas emissions from chemicals in the last 30 years by 55%, in a phase where the production has actually increased by 43%. So this is mainly due to the reduction of nitrous oxide emissions, but this also helped the European Union to build up understanding of how to regulate the chemical industry. Secondly, Europe is not only the place where many of the inventions that we use today in the chemical industry, like many plastics, were invented, but we still are a very important place for global research on chemicals. So in 2021, for example, 10 billion euros have been spent on R&D in the chemical industry, which gives us a lot of innovative strength that is increasingly also focused on how the chemical sector can reach climate neutrality. And thirdly, and I think most importantly, Europe has a very high level of ambition, and we have an emissions trading system in place. We have the European Green Deal as an investment or a support framework for the green transition of the continent, basically. And we believe that these are key policies that are already in place that are necessary to make the transformation to climate neutrality a success. So let's look at the infrastructure. I already said that Germany is very much embedded into a European chemical industry. On the left side, you can see that Germany makes up approximately 30% of the sales of chemical products in the EU. And on the right side, you can see some of the key chemical infrastructures in Germany. And what you will see is, for example, here in this part in Western Germany, we have a strong interlinkage with the chemical industry in the Netherlands and in Belgium. So there are pipelines going back and forth. There's a high integration in the production, in the value chains. And therefore, it is only possible to transition the chemical industry within all these clusters. So yeah. But Germany also has a very broad range of products. The value chains are very, very deeply intertwined, highly integrated, and that makes the German chemical industry probably as one of the most efficient chemical industries with a very broad range of products. And let's have a closer look at that. So in Germany, we produce roughly 30,000 different chemicals. But luckily, we do not have to find a strategy for each and every one of these 30,000 different chemicals, since these chemicals are mainly based on 10 very energy and emission intensive basic chemicals. These 30,000 different chemicals are used for various applications, which is shown here on the left, for example, in the plastic sector, in construction, but also automotive industry, of course, is very important in Germany. And here on the right side, you can see the dependence of some selected intermediate and end products of the chemical industry, and their reliance on the basic chemicals here in the center, and then showing the final products here on the outside. In 2019, roughly 50% of the chemical industry's final products were polymers, 37% were fine chemicals, and 11% were fertilizers, so to say, like the ammonia sector, basically. The chemical industry itself expects that the specialty chemical sector will have a modest growth, but there will be a slight decline in the basic chemical sector due to situation of competitiveness with other chemical industries around the globe. In 2019, the chemical industry added value of 70 billion euro, which is 2.3% of Germany's gross value added. Let's have a different perspective here on the chemical industry. This graph shows the energy and feedstock demand of the chemical industry. In Germany, the chemicals production accounts for roughly 10% of the primary energy consumption. And naphtha, for example, an oil-based chemical feedstock, is used as a feedstock as a source of carbon for the production of chemicals, petrochemicals. And another important energy carrier is natural gas, which is mainly used for energy purposes, so supplying thermal energy, providing electricity, but also a little bit as a feedstock in the production of ammonia. And the question is, like, how high is the ambition for chemicals here? These emissions for the production of chemicals, so Scope 1 and Scope 2 emissions, energy and production-related emissions, are regulated under the EU emissions trading system. And last winter, we have reformed this EU ETS, and now there's an emissions cap in place that is likely to be reduced to zero as early as 2039. So that would mean that the German chemical production would have to transform within the next 15 years, a very fundamental transformation. So a lot of challenges ahead of us, or ahead of the chemical industry. A different perspective is the life cycle emissions perspective, because of course, Scope 1 and Scope 2 emissions are crucial for reducing immediate emissions. But these Scope 1 and 2 emissions account for 21% of the industrial emissions in Germany and 5% of Germany's total emissions. But in addition to that, we also have up and downstream emissions. So that means in the extraction of raw materials, which are at the time being mainly fossil fuels, we have like methane leakage emissions, like greenhouse gas emissions. But most importantly, we have end of life emissions for the waste utilization in Germany. That is mainly thermal waste utilization and a little bit of recycling. But all in all, the end of life emissions account for more than 50% of the life cycle emissions of chemicals. And if we want to develop a transformation roadmap, we have to take into account all emissions along the entire value chain. We cannot just look at the production, but really make chemicals and plastics sustainable in the future. How can that happen? We have published the study that I mentioned before already, Chemicals and Transition, and there we suggest to have a set of 3 strategies that will lead us to the way of sustainable or green renewables-based chemicals. First of all, electrification. As I showed before, right now we use a lot of natural gas to supply power and heat. And instead of just replacing that with renewable hydrogen, it would make much more sense to use electricity directly, since this has a huge efficiency gain compared to hydrogen. And it is also technically possible at most of the applications. The second strategy is the circular economy, and that does not only mean recycling, but also using basic materials more efficiently. So there's quite a potential to optimize the products in terms of using less material in the first place. We also have to make sure that we can extend the lifetimes of the products that we produce, and have to enable the reuse, for example, of packaging. But of course, recycling also is an important aspect, especially for the actor of the chemical industry, which has only limited access to how products are produced in the end. So together with mechanical recycling, what we already have quite an understanding on, have already quite an understanding on that and experience, and complementing that with chemical recycling, we believe it will be possible to achieve recycling rates of up to 75%. So these two strategies, of course, reduce the demand of fossil fuels, but there will be a demand of feedstock after that too. So the remaining demand needs to be covered by renewable carbon and renewable hydrogen used as a feedstock. There we believe that biomass is a very promising resource to use, since it's already consisting of the main building blocks of chemicals, which are, of course, carbon and hydrogen. And using biomass as a feedstock in a circular economy, instead of using biomass just as an energy carrier and incinerate it, can help to also preserve natural CO2 sinks temporarily. So using biomass is in many cases more energy and resource efficient than electricity-based molecules, but of course, we probably will not be able to cover every process with a supply of biomass. So there will also be some demand for power-to-X for hydrogen, but also, of course, for imports. That is definitely also part of the chemical industry. Coming to an end with the key challenges right now. So what we believe is necessary in Germany and Europe right now is a concrete, actionable roadmap and more consensus, and of course also green markets to be able to sell your green and probably for the time being more expensive products too. The chemical industry itself has been working on transformation concepts for climate neutrality with a high pressure for around 5 years already. However, this strategic focus is really a lot on renewable hydrogen for the time being, for which the price and the availabilities are right now pretty much unclear. The chemical industry is also pretty much under pressure. I already mentioned the emissions trading system, which is probably reaching net zero or zero emissions as early as 2039. The chemical industry will also lose its free emission certificates with the phasing in of the carbon border adjustment mechanism, CBAM. And yeah, that will make conventional production more expensive. What do we need to do to enable the chemical industry to transition? First of all, we have to establish green markets. I think this is also a topic that is very important to be addressed on the international sphere. We have to improve the financing conditions for climate-friendly production sites. And of course, the main building block of the energy and industry transition are the deployment of renewables and infrastructures. With that, yeah, thank you very much for your attention. Feel free to reach out, to write me an email, and really looking forward to the insights from the other presentations. Thank you.
Thank you very much, Paul. From Europe, we'll now go to Southeast Asia, and that is Indonesia, to find out what the Institute for Essential Services Reform identifies as pillars for Indonesia's near-zero ammonia industry decarbonization roadmap. And for that, I would like to invite Faricha to give us the insights. Faricha, you have the screen.
Okay, can you see my screen now? Okay, great. So thank you again, Lydia, for the introduction, and hello everyone to everyone that joining online. My name is Faricha Hidayati, and it is such a great honor for me to join this webinar and sharing our latest study on the industry decarbonization roadmap in Indonesia. So before talking further about the main topic, I would like to briefly introduce you with our organization, IESR. So IESR is actually a think tank based in Indonesia that focuses on energy transformation, and we do this by advocating public policies and conducting capacity buildings to various stakeholders in Indonesia. To learn more about our organization and to access our data-driven publication, please visit our website on isr.or.id. And regarding the industry project, actually, ISI has been working closely with Lawrence Berkeley National Lab to working on the 5 heavy emitter industry in Indonesia. These are iron, steel, cement, ammonia, pulp and paper, and textile. And this is the ammonia industry in Indonesia. So currently, Indonesia is the 5th largest ammonia producers in the world, with annual production in 2020 reached about 9.5 million tons per year, or equivalent to 5% of the global ammonia supply. And in Indonesia, ammonia production plant is integrated within fertilizer industries that are scattered mainly on the 4 main islands in Indonesia. We can see here there are 7 individual companies in 2022 that actively produces ammonia. And in the same year, 27% of the produced ammonia is being exported, whilst 73% of them is used domestically, mainly for the fertilizer production. And apart from the production scale, actually ammonia is one of the most emission-intensive commodities. To give you an example, for every ton of ammonia, its average direct emission is currently 2.4 tons of carbon dioxide, or almost 2 times higher than crude steel and 4 times higher than cement. Given that huge number and multiplying with the total production in the world, so global ammonia production accounted for about 2% of total final energy use and responsible for the generated CO2 of about 1.3% globally. And this is the process diagram of the ammonia production. In a nutshell, the emission sources mostly came from the hydrogen production, more than 50%, where the natural gas is used excessively for feedstock. And the rest of emission from ammonia production is generated due to the high thermal energy required to allow the chemical reaction to happen and to condition the reaction chamber to have a certain pressure to speed up the chemical process. And then this is our decarbonization pillars for ammonia production. Currently, we propose 4 main decarbonization pillars, including material efficiency, energy efficiency, green ammonia, and the utilization of carbon capture and storage. And from the right side of the slides, we can see the projection of the national production capacity based on the historical database. And it is estimated there will be a substantial increase of ammonia production in Indonesia. We can see from the data in 2020, currently we, the 2020, actually, we produce about 9.5 million tons of ammonia. And with 90% of them is produced using natural gas, and the rest of the production uses coal gasification process. And if we follow the business as usual trend until 2060, there will be an increase about 21% of ammonia production in 2060. And by implementing material efficiency, such as increase the uptake efficiency of fertilizers to reduce the waste from the food waste, and then reduce increase the recycling of plastic, we can decrease the future ammonia production by 7% in 2060 and 12% in 2015. And on this graph also, we give some illustration of how technology can help to decarbonize ammonia production in Indonesia. So there are currently four main pillars, 4 main strategies for the technology implementation. First is to eliminate the use of coal. And then the second one is to increase the electrolytic ammonia production. And then third one is to couple the unabated natural gas with CCS technologies. And the fourth one is to increase the adoption of methane pyrolysis and biomass-based ammonia production. Okay, so this is the graph that's showing us the potential emission reduction by the different routes on the 4 decarbonization pillars. We can see here that in 2020, the calculated emission from Scope 1, Scope 2, and partly Scope 3 from the urea usage in fertilizers. It is currently, Indonesia has emitted about 26 million tons of CO2 per year in 2020. And in this scenario, in 2060 scenario, total emission is expected to decrease to be around 4 million tons of CO2. So implementing strategies like energy efficiency measures and green ammonia will contribute to the avoidance of 5 and 17 million tons of CO2 respectively. Meanwhile, the adoption of carbon capture storage will help eliminate another 4 million tons of CO2. And the last one is to decarbonize power sector, in which in our study we do not make the modeling, but we assume that there will be like Indonesia will achieve net zero in 2060 for the power sector. And this is for the similar with the previous one. This is for the second scenario, the accelerated 2050. And by we use like a CRIS approach, and it will be resulted avoiding another 2 million tons of CO2 per year. Okay, so reflecting on the decarbonization roadmap, actually Indonesia has huge potential to become champion in zero ammonia goal. There are 3 reasons underlying this statement. The first reason is like Indonesia industry stakeholders are currently have high awareness toward this timely issue, and most like especially the one that is under the holding company of PT Pupuk Indonesia is already have the decarbonization roadmap, and as well as they already like have some pilot projects on green ammonia technologies. The second reason is Indonesia has fast renewable energy resource potential up to 3.7 thousand gigawatts, which will help like decarbonize the power industry and will give like a enough supply, a biomass supply for the green ammonia technologies. And then the third reason is like Indonesia has already good foundation on its policy instruments, although some not applied. So most of it are still low bindings and has no clear targets. Such policy such as the voluntary green industry standard, and others like emission quality standard, national renewable energy target, and carbon trading. Okay, so this is the last slide for me. So the policy recommendation that we propose to the policymakers, the first one is to define a clear emission reduction target for ammonia industry as soon as possible, because currently Indonesia has no target on the industry decarbonization at all. And the second one is to improve permitting process of building renewable energy captive power. And the third one is to start developing programs to build local community skill on the future green job. And the fourth is to accelerate the development of carbon capture and storage, regulation for downstream industry. And the fifth one is to provide incentive for financing green project, and lastly to develop national green hydrogen strategy. Okay, that's all for me. Thank you so much for listening. I'm sorry for the rest explanation, but I will. I hope that if there is a question regarding to it, like, I will gladly help to answer it. Thank you so much. Back to you, Lydia.
Thank you very much, Farisha. Yes, indeed, the presentations will be available on GESI's website, and we will have the possibility to address some of the questions both in the Q&A box, and please use it, and then in the Q&A session at the end of the event. For the next presentation, we will stay in Asia, albeit look to another country, and that is to China. And China's perspective for powering up chemical sector decarbonization with renewable energy will be presented by Isadora Wang from Agora Energy Transition China. Over to you, Isadora.
Thank you, Lydia, for your introduction, and thank you, GESI, for organizing this excellent webinar. I'm very happy to be here. My name is Isadora Wang, as Lydia has already introduced. I work for Agora Industry and Agora China, and based in Beijing. And in China, we have already published a paper to promote the industry application of renewable hydrogen in China to be prioritized, and also to curb the coal chemical sector growth in China. So today I will share with you our research findings on how to power up China's chemical sector decarbonization with renewable hydrogen in China. So first, let's have some quick facts about petrochemicals and coal chemicals in China. So in China, the revenue of China's petrochemical sector reached 16.6 trillion Chinese yuan, which is almost 2.4 trillion US dollars last year. This accounts for about 12% of China's national industry revenue, which is quite a lot. The emissions, the GHG emissions from the petrochemical sector and the coal chemical sector in China adds up to 13.4% in China, including Scope 1 and 2. And I'd like to bring your attention more to the coal chemical sector in China, because unlike Europe or Indonesia, which are more based on petroleum or natural gas, much of China's coal chemicals are coming from coal, actually. In China, 4 billion tons of coal are consumed each year. Among them, 21% of the coal are processed by the coal as feedstock in the coal chemical sector, including coke manufacturing for the steel sector. With now the coal phasing down and coal phasing out circumstances, China's coal sector is looking for a way out to maintain their coal mining and coal processing industry and facilities, which is to find their opportunities in the coal chemical sector, which is not something we would like to see, because using coal to produce chemicals has the biggest CO2 emissions and comes with a lot of pollutions. But luckily now, because China wants to manage its coal consumption and prioritize for energy use of coal, China has just released this year a policy document to promote the healthy development of modern coal chemicals, which elevated the approval process of newly added coal chemical facilities, which in some ways also helps prevent stranded assets. If you look at this diagram, it shows that how hydrogen is being used in the chemical sector in China. You can see that only 9% of the hydrogen consumption in China are for oil refining, and the majority are actually coming from coal and being used by coal chemicals. As I have mentioned, in China is quite unique and also different from other parts of the world. 81% of China's ammonia come from coal, and 76% of China's methanol come from coal. If you look at the right side of this diagram, you can see that most of the ammonia goes to the downstream sector in agriculture use, for example, as fertilizers. And the rest, 30%, are used in the industry sector for pesticides, explosives, etc. For methanol, the downstream is mostly ethylene, and you can see that 15% of the methanol are being used as fuel. There is a trend actually in the future to use methanol as somehow clean fuel, and also using green ammonia as the ship fuel. There is a big interest actually in China already on replacing the coal-based hydrogen with renewable sources, with a lot of installation of solar and PV power generations. In this slide, you can see some of the demonstration projects already being constructed in China. The project on the left is developed by an SOE called China Energy Engineering Group. It is a project using solar power and PV to produce hydrogen and then to ammonia to methanol. This project in Songyuan, located in Songyuan City, Liaoning Province, has a capacity of 800 megawatts of renewable power generation, and also 245,000 tons of green hydrogen, and also 200,000 tons of ammonia production each year. It has started construction in September this year and will help decarbonize the ammonia and methanol production in China, and also provide a pilot demonstration. The picture on the right side is the project invested by Sinopec in Xinjiang province in China. It has already been commenced production. The basic concept of this project is to mimic all the supply chain of green hydrogen. Actually, it uses solar and PV to produce renewable power, and then transmit the power to electrolyzers, and then using pipelines to transport all the green hydrogen into the refinery in another city in Xinjiang province, and store them in the sphere tanks you can see in the picture. And then those hydrogen are being used in a refinery to replace all the natural gas being consumed there. This project is set to help reduce 500,000 tons of CO2 emission each year. But there are many these kind of pilot projects in China, but they are not sufficient in decarbonizing the chemical sector because the cost of these demonstration projects are very high. Maybe some of you notice that all of the investments are made by state-owned enterprises because they have this political will to invest in these demonstration pilot projects. But if we want this to be like a new normal or to really replace the fossil fuel-based chemicals in China, then we need more incentives. First of all, it might be strange to some of you, the power price plays a key role here because the intermittence of solar power and PV does not really secure renewable hydrogen production. So usually those projects feed into, like, they sell the renewable power to the grid, and they get the electricity from the grid to maintain their production and remain secure. So under the current industry power price in China, the green ammonia and methanol are cost 2 to 3 times the cost of coal-based production, which means we have to reduce the power price for green chemical production by 2 to 3 times in order for them to be cost effective as the coal-based, their coal-based equivalent. Another thing I think is what Paul have just mentioned, to use the green lead market to really give the green premium to the green products. For example, another good policy we have observed from the European Union is the carbon contract for differences, which subsidize the investment of green investment. Currently, China's chemical sector has not been included in a national emission trading system. It is said that by 2025, all the industrial sector, like major industrial sectors like chemicals, iron, steel, and cement will be included. But I personally don't think the chemical sector will be the first batch to be included, which also adds to the new challenge of, bringing down the cost or shifting it to its downstream. Under the current circumstances, if with no other policy tools, if chemical sectors say that it's included covered in the national ETS, then the carbon price has to be about 336 RMB per ton of CO2 to make the green ammonia and green methanol to be the same price as the fossil fuel-based ones. So this leads to our analysis of the decarbonization pathways of China's chemical sector. The first and foremost, I would also like to quote Paul, efficiency and electrification. I'll elaborate a little bit on efficiency. For example, we can use better catalysts or recycle the heat so that the general efficiency of the chemical production process could be improved. In the past 5 to 10 years in China, actually, there are some achievements. For example, per each ton of olefin from methanol, the consumption of methanol has dropped by 20%, which is a big step, and it's expected to be improved further in China. For electrification, there are 2 different perspectives. The first perspective is to replace coal heating with power, for example, in the steam crackers of naphtha. And the second layer of this electrification is actually to electrify the downstream oil or chemical using sectors. For example, the transportation sector. China is developing a lot of the electric vehicles and fuel cell vehicles just to cope with the lack or the reliance of import of gasoline. The third pillar for decarbonization of the chemical sector in China is to use green feedstock and replace them, like replace fossil fuel-based hydrogen or fossil fuel-based raw materials with renewable hydrogen. The fourth pillar is also circular economy. This is quite similar to what the Europe and actually Indonesia experts have just mentioned. Currently, the plastic recycling rate in China is 30%, which is almost twice the international level, but it's still far from sufficient because we still have 1/3 being landfilled and another 1/3 being incinerated. If we could really, like what Paul has said, increase the recycling rate to 75% in the future, then this will help reduce a lot of plastic consumption and also CO2 emissions. Yeah, thank you for your attention. This is all about what I want to share today. If we have more questions, happy to discuss in the chat box or in the panel discussion. Thank you. Back to Lydia.
Thank you very much, Isadora. I have seen one question appearing in the Q&A box and the other one in the chat box. I would encourage the author of the question, the chat box, to just put it in the Q&A. This way we are going to have more clarity about what we're dealing in which box. But thank you, Isadora. This is definitely a challenge to plan for decarbonization of such a big market that China has. But it's also good to see the light at the end of the tunnel and for efficiency, electrification, grid feedstock, and circular economy. And having learned it, we'll look into another big market, but on another continent. And I would like to invite Leonardo Teixeira, who will take us to Brazil to introduce us to the current perspectives on the decarbonization of the Brazilian chemical industry. Leonardo, please go ahead.
Thank you very much, Lydia. Thank you for the invitation. Let me share my screen here. Okay. So once again, I'm Leonardo. I'm a coordinator at Senai Innovation Institute for Biosynthetics and Fibers. And today I'll talk a little bit about the decarbonization of the Brazilian chemical industry. Prior to going to the theme, I want to introduce you my institute. So our mission is to develop sustainable solutions through industrial chemistry and biotechnology. We're using both renewable and non-renewable resources to generate new products and processes. We are organized in 5 areas. So we have a competitive intelligence area that I coordinate, but also biotechnology, process engineering, fibers, and chemical synthesis and analysis. And as an applied research institute, we support multiple industries like agrochemical, food and beverage, energy, paper and pulp, textiles, and so on. Regarding the Brazilian chemical industry, we are the 6th country globally in net revenue. Our chemical industry mostly focuses on the basic chemicals, thermoplastics, fertilizers, and pesticides. And as a relevant characteristic of our chemical industry, we are heavily reliant on imports, mostly of fertilizers here. They have a large contribution to the trade deficit that we have here in Brazil. Regarding our indicators, in the last 10 years, we have seen reductions in both primary and secondary energy consumptions, mostly on secondary energy consumption. So this leads to Brazil having CO2 emissions intensity around 51% lower than the average for 47 countries associated to the International Council of Chemical Associations. And this scenario is mostly related to the changes in energy matrix. So Brazil is increasingly using renewable energy like hydraulic power, and also the implementation of more efficient heating systems in our multiple processes. Regarding our challenge in decarbonization, one major challenge for Brazil is the relevant CO2 emissions related to the transport of feedstocks, inputs, and products. Brazil does not have extended railroads, and we also have a high cost for short sea shipping. So we rely heavily on trucks to the transport of chemicals. And since our country is very, very large, this represents a lot of emissions. Also, there is a problem to medium and small sized industries in terms of access to financing for the green transition, and also a general absence of specialized labor force to deal with the new technologies that are coming to contribute to decarbonization, such as green hydrogen. Despite these challenges, we have some solutions being implemented. So we are expanding here the use of clean energy sources like biomass from sugarcane, wind and solar power, implementing cogeneration systems, electric motors, N2O abatement systems, such as in nitric acid adipic acid production. So here in the right, I show you an example of Roger Solvay plant that has been operating since 2006 and focus on adipic acid plant abatements. And we also have initiatives, for example, from the National Industry Confederation to establish partnerships to qualify labor to deal with the new technologies related to decarbonization, including hydrogen and biofuels. A major opportunity that I see for Brazil here is the so-called the bio-based circular carbon economy. So it tackles decarbonization through the simultaneous use of renewable energy, biomasses, and CCUS. So for Brazil, Brazil has a great comparative advantage regarding biomass. So we have a lot of major renewable value chains in place, such as sugarcane, corn, soy, paper, and pulp. And we can integrate these biomasses in a economic model that use also renewable energy, for example, to produce hydrogen, and also think of the circular carbon economy, which means that we can use CO2 emissions and CO and so on as feedstocks for chemicals, fuels, and other products. So with this, what we see is that we have blurring boundaries between the chemical industry and other sectors, including here paper and pulp sector, sugarcane production, energy utilities, and so on. So I think the future directors for a more integrated industrial system. To exemplify the potential of the bioeconomy to Brazil, I bring here the results of a study we carried with the Brazilian Association of Bioinnovation Association. So it's a study that is focused on the measuring the potential of the bioeconomy to decarbonize Brazil. So in this study, we use an integrated model of emissions to quantify the emissions of Brazil until 2050 and also the revenues that the bioeconomy can potentially generate to the country by then. So we have three scenarios here. So we have a base case scenario, which is we called current policy scenarios, in which we maintain the mostly fossil-focused policies that we have today until 2050. So in this scenario, we have accumulated CO2 emissions of 40 gigaton of CO2 until 2050. If we come to an intermediate scenario, which is the WB2 or well below 2 degrees, we are able to meet the Paris Agreement and have accumulated CO2 emissions in the order of 14 gigaton of CO2, with revenues in the range of $245 billion per year. The third scenario, which we call the bioeconomy scenario, we take the technologies that we implement in the WB2 scenario and expand them using bioeconomy related technologies, which are these ones I put here on the left. So in this scenario, we reduce further our accumulated CO2 emissions to 13 gigaton for CO2, but our revenues increase to $392 billion per year, with an investment of $67 billion. So with this, I can show you that we are able to use innovation as a driver to mitigate CO2 emissions, respect the Paris Agreement, and also generate a lot of revenues for the country. And once again, we need to think of the chemical industry associated to other industries and other sources of innovation. Just a remark, we are releasing a new study probably this year when we add more 10 technologies to this bioeconomy scenario, and as I can say that the results are even better. The potential of the bioeconomy is even better to mitigate emissions and generate revenues to the country. So very quickly, that's all I had to share to you. Thank you.
Thank you very much, Leonardo, for these insights and ideas how to approach the Brazilian chemical industry decarbonization case, and also to look beyond to agriculture, to biomethane and other means that can be used. And we all know that every single sector will need to do its part to achieve climate neutrality. Today, we are looking at chemical sector, but there is definitely much more to do. And last but not least, I will ask the host of today's event, the Green Energy Strategy Institute, for the information and ideas around the Korean chemical sector. And Boram, please take over.
Thank you for the kind introduction. Let me share the slides. Let me begin. I'm Boram from GESI, and here to share some of our works on navigating the future of the Korean chemical industry in a carbon neutral society. So we've been working on this topic for the past year, and we discovered that it's such a challenging industry to decarbonize, hence why we decided to host an international webinar as such, to listen to perspectives in other countries, and definitely it seems equally challenging in other countries. The presentation will follow in this order. Just to give you a brief background, since we have a lot of international audience, Korea is the 8th largest energy consumer and very much reliant on imported fossil fuels with very little renewable energy. And chemical industry has a very high influence and presence in the economy as the 2nd largest exporting industry next to semiconductors, and production accounting for 30% of total manufacturing sector. But here today, we're going to focus mainly on petrochemical industry. And as we have discovered in the previous presentations, chemical value chain can be very broad, encompassing thousands of different products for a different country. But in Korea, it can be generally divided into 3 segments. The first is the oil refining industry. We call it a refining industry. And then where it produces fossil feedstocks for petrochemical industry, where it produces basic building blocks like olefins and polymers, and which is called as petrochemical industry. And then there's more downstream industries that uses these feedstock to produce more familiar consumer goods, like, as we know, rubber, plastic, and so on. And the reason why we're focusing on petrochemical industry today is because it is the 2nd largest industry that emits carbon emission, accounting for almost 11% of countries' total carbon emission when including electricity and heat. To give you a more visual overview of the value chain, we've tried to simplify the current value chain as such. And as you know, as I've mentioned, we have a refining industry that produces feedstocks such as naphtha, and our country is very much oriented naphtha-oriented steam cracking to produce basic chemicals such as ethylene, propylene, benzene, xylene, and so on. And interesting to note that unlike Indonesia, we don't produce ammonia. We actually import a lot of ammonia from Indonesia. And from the basic chemicals mentioned here, we produce polymers such as polyethylene and PET, as we all know. And looking at the energy side of things, this is the energy Sankey diagram of the entire industry. So starting from, the very right after the refining sector. So as you see here, the 80% of the entire industry is used as feedstock and 20% as process energy. And within this feedstock, 88% is constitutes of naphtha, so very much naphtha oriented. And we also have, other feedstocks such as propane and butane. And if you see the process energy to supply heat and electricity for the production, also very relying on fossil fuel energy, oil, gas, and coal, and such on. And just to explain why our country is so oriented, naphtha oriented, I think it'd be a good chance to explain the background of our refining industry, which is quite significant. So as you see in this material flow Sankey diagram, mainly for petroleum-based products, we have quite a big oil refining industry that through fractional distillation produces transportation oils such as diesel and gasoline, and half of them are exported to countries like China, Japan, Singapore, and Vietnam, and so on. And as a byproduct, naphtha and other oil products are produced, and they are used as feedstocks for the petrochemical industry. And here, as you can see, it's processed to produce high-value chemicals such as ethylene and propylene, olefins, and BTX, and they're also processed further down to produce polymers such as composites and synthetics and so on. And as you can see here, half of them are again exported to other countries. So the bottom line is that we are very much export oriented, dependent on imported petroleum oil. And the implication is that because of the presence of such large refining industry, there is a fossil fuel lock-in effect due to the current petrochemical industry integrated deeply into the refining operation. So it's a quite challenge to decarbonize in such intricately integrated value chain. And looking at the emission side of things, we try to estimate the life cycle emission distribution as also shown in Agora's presentation, starting from naphtha production to end of life. We've figured these values, and it comes down to three main points I'd like to emphasize. The first point is that over the course of time, direct emission coming from the process has reduced continuously owing to environmental regulations and efficiency improvement. And we've met quite a lot of industry stakeholders, and they emphasize how our industry efficiency standard has reached top level, and this implicates that for further reduction, there are technical options available such as carbon capture storage, electrification, and also providing renewable heat such as ammonia and hydrogen. And the second point is that, as you can see here, there's a lot of decarbonization potential within the grid system. So energy transition within the grid can also reduce the entire life cycle emission by almost 30%. So yeah, there's a very importance in expanding renewable energy in our country. And finally, even the technology options I mentioned, let's assume that even with so many barriers, they are relatively more technically viable compared to the significant end-of-life emission here, which is half of the entire life cycle emission. And for this, the fundamentally requires a substitution with alternative feedstock, such as using circular economy and biomass and so on. And since there have been quite many qualitative analysis and reports published on how to decarbonize this challenging industry and especially on feedstock substitution, but there has been quite minimal effort in quantitatively analyzing the substitution and especially using bottom-up data. So GESI, we over this year worked with carbon mines and to develop strategies to replace the current fossil fuel-based carbon demand. And it comes down to basically 3 strategies. First is to use biomass, and second through circular economy, mainly from collected plastic waste through mechanical and pyrolysis, and the leftover would be met with sustainable hydrogen and carbon dioxide. And for this, we did a quantitative analysis and calculated all the carbon demand required to produce the basic chemicals for 2019 level, which was pre-COVID, and in order to meet this carbon demand, what we did was from using nationally available data, we calculated how much carbon can be retrieved from recycling, assuming 73% recycling rate. Currently, Korea is recycling about 18% of the collected waste, and rest is being mostly incinerated. So assuming 73% of recycling and prioritizing mechanical recycling and then chemical recycling, we can see that it's quite insignificant compared to how much we need. And as a small country, unlike Brazil, we have very limited biomass resources. And here we try to utilize only nationally available biomass potential because as you know, it's very energetically inefficient to import biomass, and so we try to, and also there's a lot of competition with other sectors, so we prioritize unused biomass potential from wood and grass. And also the second option would be to use the currently energetically used biomass, such as wood and so on. And even with that, with the effort, we discovered that we still require about 70 to 80 million tons of carbon dioxide, and also around 12 million tons of green hydrogen to produce green methanol, to produce basic chemical that's required to meet the current demand level, which is assumed to increase in the future. And as I've shown in the previous slides, the emission from the process emission from the industry releases about 10 million tons. So it's quite small compared to how much carbon dioxide is needed to meet the current demand. So to wrap up, like to just emphasize on a few lines. Chemical industry is such a complex industry and requires effort across the entire life cycle. There's no one for all solution. And second, acquiring alternative feedstock will be a biggest challenge in Korea. And how can we close this loop? There's got to be put in a lot of thought in this, and like today, I think needs to be more open dialogue and also a very concrete scenario based roadmap especially with life cycle carbon emission assessment. And to achieve this, alongside of what I mentioned, we also need government's efforts to provide consistent and clear decarbonization policy to signal businesses and incentivize decarbonization. That's all from my side. Thank you for listening, and back to Lydia.
Thank you very much, Boram. Your presentation gave us actually quite a good segue to the second part, in which we'll discuss the implications, challenges, but also more detailed solutions, as well as the questions from the audience. I would like to mention that the presentations are already available on GESI's website. So if you want to look through them while we discuss some things in the second part, please do so. I have also seen some movement in the Q&A box as well as in the chat box. I would like to reiterate that we'll use the Q&A box to answer to look at the questions. So please put them over there. Obviously, the questions in the chat box are already there, so we'll try to address them as well. But for now, I would like to invite you to the second part that will feature all 5 of our presenters. And this part, this panel discussion will be led by Pil-Sok Kwon, GESI's director. And yes, I think we are ready to start the second part. Pil-Sok, you have the screen.
Thank you, Lydia. Yes. While I'm hearing your presentation, I'm a little bit sorry for you to make yourself very hurry up because of the limited time. And I think that chemistry is quite complex and very difficult to issue, but it's quite difficult to summarize your country's status in 10 minutes, and then also the decarbonization roadmap in 10 minutes. So for the future, I hope that we have another session for this kind of things for the long period of time, with a long duration of the time. So then I have some question to the with the order of the making presentation. So I will ask some individual question to the each presenters. So in the order of the making a presentation. So the first question is the Paul from the Agora Industry. Do you think the focusing on the specialty chemicals while reducing basic chemical production is a good strategy to decrease overall carbon emission in the chemical industry? Please answer this question, Paul.
Yes, thank you very much for the question, Pil-Sok. So to be clear, that outlook of the chemical industry that the production of basic chemicals will reduce slightly over the next years is not a consideration of climate protection. So it rather is considering the different competitiveness aspects. And when it comes to competitiveness, you have different sectors, different elements. Of course, energy costs play an important role in that, but also existing infrastructure, the access to skilled labor or skilled people, the access to research and development. And looking at this set of different factors of competitiveness, it really makes sense for Germany to focus on high engineering chemicals and plastics and not on basic chemicals. So basic chemicals, the production of basic chemicals has been invented a long time ago, many decades ago, and that is something that many countries and many people all over the world can do. And since Germany has rather expensive energy costs at the moment, it is just more competitiveness for companies to produce not in Germany, but in other countries. But on the other hand, we are very strong in the production of specialty chemicals and fine chemicals and inventing new things. Yeah, that is the main reason. But it is clear that just outsourcing basic chemical production cannot solve the climate transformation problem of the chemical industry. So when it comes to sourcing basic chemicals for the downstream production, we have to make sure that these basic chemicals are based on renewable energies and feedstocks. And there comes this international discussion into debate, of course, and that the chemical sector has to be moved towards climate neutrality internationally and not only in one country.
Yeah, thank you for answering that question. I think global cooperation is quite important for that matters. And then second question to the Felicia, and I heard that Indonesia is the fifth largest producer of ammonia. That I understand you have proposed plans to decarbonize the production process, mainly using green hydrogen and carbon capture and storage. Regarding this, what is the most imminent and practical action that must take place now?
Okay, thank you so much for the question, Pilsak. So let me refresh our memory first on the 4+1 decarbonization pillars that we propose. First is material efficiency, second is energy efficiency, third is green hydrogen and ammonia production, fourth is the utilization of CCS, and the +1 is the decarbonization of power sector. So following your question, so based on our study, actually, all of these strategies are complementing each other and answering different problems by ammonia industry in Indonesia. So for example, CCS is targeted to decarbonize the newly built ammonia plants that currently like 5 to 16 years of newly commenced plants, and then the green hydrogen technology to substitute the other plants that already like have the operation more than 30 years plus. So existing implementation of this technology is also but existing implementation of this technology actually is very limited due to the initial cost, and considerably Indonesia is still lacking of the technology, both technology. So we need to, I would say that these two strategies is not in the near term. So for these two strategies, especially Indonesia will need to develop long-term technology roadmaps that should carefully consider the selection of sites, permitting requirements, and also access to the renewables. But for the other three strategies, so energy efficiency, Indonesia is actually in terms of ammonia industry is quite advanced compared to global ammonia energy efficiency. So in our study, we estimate that the average energy intensity of ammonia production in Indonesia in 2020 is 37 gigajoule per ton on a net basis, while on the average global energy intensity of ammonia is now in 2020 is 41 gigajoule per ton. And whereas the best available technologies for a natural gas-based ammonia production on a net basis is 28 gigajoule. So I believe other than the nearest strategy that is very visible for Indonesia to adopt is the implementing the energy efficiency measures, because it is like the long-hanging fruit and also like requiring the least initial investment and can be implemented easily in the near future. Thank you.
Thank you for the answer. Then I guess that is a renewable energy expansion is quite most important things to do for the present time. And then the third question is to the Isadora one, and I would like to ask a question like China is still growing its production capacity for chemical products like South Korea due to rising demand. And I would like to ask if this increase in capacity is designed for the using fossil fuel. Well, I'm not sure. And when I hear your presentation, then I think that China is already have a different path for the increase in capacity. So if so, then if I'm wrong, and then China still is depending on the fossil fuel for the increasing production capacity of the chemical industry. How could China avoid the risk of the stranded asset?
Thank you, Pilsak, for your excellent question. I think you are right. Yes, China is facing an increasing demand of chemicals in the future. And I don't know how familiar everyone is familiar with China's like carbon pledges. China has made this promise to peak carbon emissions by 2030, nationalized, and reach carbon neutrality by 2060. But it will be achieved sector by sector. So chemical sector is not expected to be the first batches to peak their carbon emissions. They are expected to peak beyond 2035. So between 2035 and 2040, the chemical sector will one by one peak their carbon emissions. The question of trying to avoid stranded assets is excellent one, because there are not so much discussion in China currently about anything about, like, in the chemical sector, in the iron steel sector. No one cares about stranded assets, as if they don't have to worry about it. So one of the things I think we could do as civil societies is to build the awareness for the government agencies and also for enterprises that, if you start to build too many new capacities in the future, it will be a big problem. Because, for example, most of the methanol ammonia facilities in China have only been running for 7 to 15 years in China, but their lifespan could be up to 30 or 40 years actually. So we have to, like, during the planning of coal chemical facilities, you have to plan about this. So there is some, like, a role for the government to do a macro planning, and also there is also, like, room for the sector to better organize its resources deployment. That's what we like to say. And another aspect is actually to replace materials, like from the demand side, you replace all those chemicals with other materials. For example, recently, just this month, China released this policy on using bamboo fiber to replace part of the use of plastics in the wrapping, in tableware, in furnitures. So if this could be implemented well in the future, hopefully it could help like cut some of the chemical demand, the rising chemical demand. Thank you.
Thank you, Isadora. It's very impressive because we have the same problem, because we also have a big problem of stranded asset for the industry. So I think this is energy transition think tank's role is to give a warning to the government to stop the, fossil fuel-based investment. So I think that is our role. And then also it's very interesting to listen to the bamboo story. It's quite interesting. So the next question is that Leonardo, and I think that I envy your country because Brazil has an abundant biomass potential, which is intended to substitute, but it is this biomass potential and biomass resources should be shared with the other industry, like a steel industry. So then how can those biomass be optimally utilized for the carbon neutrality? There is any prior order for using the biomass?
Thank you, sir, for the question. Yeah, for Brazil, I think one of the main challenges right now is to measure the potential of biomass, thinking about as feedstocks to chemicals and also as energy supply. We do not have in the country yet reports such as the billion-ton report of the US, for example, to measure our potential of biomass supply. What I can say is that, in my opinion at least, I think there are multiple sources of biomasses and energy that can supply not only the chemical industry, but also, for example, the steel industry. So for the steel industry, we are talking a lot about green hydrogens, such from electrolysis as an energy vector, but we also can think about biomethane reforming to produce low carbon hydrogen, ethanol reforming to produce hydrogen as well. Besides all for example, using vegetable oils as source of fuels like biodiesel, HVO, CO2 as a source of raw material to sustainable aviation fuel and so on. So I think that for Brazil, the main challenge actually is to, among this myriad of alternatives, is to find those that are cost competitive and that make sense in local terms, because Brazil is a very, very large country. So it does not make sense to transport, let's say, a new fuel, a biofuel, from the south of Brazil to the north of Brazil, because all the emissions we have there would not be interesting in terms of greenhouse gases. So yeah, I think this is the main challenge for Brazil right now. We do have a lot of potential, but we need to go further in this agenda.
Thank you for the answer, but I think it's quite interesting because Brazil is a very large country, contrary to the South Korea. So you have to plan geographically to locate the which location is the fit for the chemical industry or the other industry complex. Okay, that's quite interesting perspective. We we just missed that. Okay, the last question is Oram. Then I would like to ask a question is that what do you think the biggest challenge in mobilizing South Korea's private sector chemical companies to decarbonize?
Thank you for the question. Amongst many barriers, I'd like to emphasize the policy risk. I think it should be more consistent and continuous to give a more long-term signal to these businesses so that they can make concrete decisions based on those policies. For example, like recently, the government has also reduced the government's industry emission target, and currently it's less than 1% yearly for to reduce yearly emission, and because these emission targets are also aligned with emission trading system allowances, it would definitely signal the businesses to prioritize decarbonization if depending on the government's decision, and also the government has reduced the R&D investment for decarbonization technologies by almost 80%, and this would massively delay the commercialization deadline, hence emission reduction by the industry. So I think it's very important for the government to have a very sustainable and consistent target, and so that businesses can make decisions. And also would like to emphasize on the optimization of feedstock usage. So coming to circular economy, so as I've mentioned in my presentation, it's very important to prioritize mechanical recycling and to be able to reduce the amount of basic chemicals required for plastic production and so on. But currently in Korea, a lot of plastic waste is used for as fuel in the cement industry, and the country currently acknowledges that as and labels that as recycling, and it would definitely lead to a competition in terms of using sustainable feedstock. So I think working on these policy instruments and making a priority so that we could maximize the carbon emission reduction with so little resource we have.
Thank you, Boram. Thank you for the answer. And I would like to start with some common question session. So I will ask some common question to everybody. And the first good question is that what is the biggest challenge or concern in decarbonizing the chemical industry in your country? And then do you think that international cooperation like today or for the future that can help alleviate these issues? So then I think that Leonardo has some should leave early then. So I would like to ask a question to Leonardo first to give a privilege to answer first.
Thank you, Piusel. Yeah, for Brazil, I think one of the biggest challenges right now is related to the fertilizers consumption. Brazil is heavily reliant on the imports of fertilizers, and since we are an agro-industrial country for large agro-industrial production. This means both in terms, we have an issue here with national security, but also we consequently rely on a most fossil-based resources. And besides that, we have also a challenge in terms of fuel. So although we have a petroleum production, we rely also on imports of derivatives. So to tackle these issues, I think international cooperation is crucial. So, for example, when we think about green ammonia and the electrolysis to produce green hydrogen, Brazil do not have its own national technologies in electrolysis, for example. So cooperation in this term is necessary for us to learn from foreign experience, develop our own technologies, and also be able to establish our own, let's say, fertilizers industry. In terms of fuels, I can say, for example, that we also would benefit from international cooperation. So, for example, we have a project with Repsol here in Brazil, with partnership from Fraunhofer Institute from Germany, to develop a technology to convert CO2 and green hydrogen to fuels, lubricants, and so on. So for our country, international cooperation would be crucial to guarantee that we have a decarbonized chemical industry in the future. So yeah, I can say that.
Okay, thank you. Leonardo just says the Brazil is needs fertilizer, and the technology aspect that it needs global cooperation is quite essential for the technology. Okay, then I would like to ask the same question to the Paul.
Yeah, I think we already touched upon that a little bit. Like, what is the biggest challenge in decarbonizing the German chemical industry? As I mentioned in my presentation, I think most importantly we have to get to an actionable roadmap. Right now, of course, we have these climate targets ahead of us, but I think in the strategy how to achieve the climate targets in the chemical industry, we are not far enough yet. Like, there's a strong focus on just having a lot of very cheap renewable hydrogen at the moment in the debate, and I think the government and the chemical industry itself, and also the civil society, they have to find an actionable, an agreeable roadmap how to reduce emissions within the next 15 to 20 years. And once we have a roadmap that is not only focusing on hydrogen, we can also start the decarbonization now. So what I hear a lot in the discourse is that the roadmaps that are, or the strategies that are out there, they always start and implementing in the 2030s. But actually, we have our climate targets also for 2030. We have to start now investing into new climate-friendly production. And we also have the technologies available with direct electrification, for example. It would be possible to really significantly reduce the production, the emissions in the production of process steam, for instance. And also right now is the time to set up the policy framework to enable high recycling rates, to enable the use of biomass. And I think once we have more consensus in the debate, we can also accelerate the processes of developing policy instruments that we need to make this actionable roadmap happen in reality. And yeah, I think this is the most important. And from an international perspective, I think it would be very, very helpful to talk more about international standards, about how we can establish green markets across the borders. And I think it would be also a great opportunity to talk about this on the Conference of the Parties, the COP, which starts next week.
Wow, it's a very interesting answers. I totally agree with that. We need an actionable roadmap. So we just stop the planning, and I think it is time to implementation is rather than having some more fancy plan. And also it's very interesting to mention of the green standard, green green cooperation for the start of the decarbonization of the chemistry industry. And then the same question I would like to ask is the same question to the Felicia.
Okay. So currently in Indonesia, there are all I think is there are two main challenges that to decarbonize Indonesia's chemical industry. First is like the electricity power in Indonesia is currently heavily reliant on coal, and both generation and transmission of the electricity are solely controlled by only one state-owned enterprise, and making this difficult for industry to establish their own RE captive power or to opt in only renewable energy power directly from independent power producers. Second is high initial investment costs and limited technical capacity of the workforce in Indonesia when adopting the low carbon technologies. So I believe that international cooperation will indeed play a vital role in alleviating these challenges by collaborating with Indonesia to have like clean technology transfer, to provide financial support and investment, and also to conduct capacity buildings to help improve workforce capacity, workforce technology capacity, and also to help facilitate building a firm regulatory framework for decarbonization. Because currently, there are like quite for each of the ministries in Indonesia, they are requiring they are mandated for each industry to report their emission, report their waste, report their energy usage, but it is still redundant from each other. And this is one of the points that we need to like focus from this point on to like make the roadmap become like a reality. Thank you so much.
Thank you, Parisha. Yeah, I think you mentioned about the regulation framework for the global cooperation. I think that is Paul and the other panels already they mentioned about the ETS and the CBAM. I think it's a quite interesting question to. It is enough to make a successful the regulatory framework to having a CBAM or ETS, but there are a lot of exceptions and there are a lot of factors not to make a successful regulatory framework. So then I would like to ask the same question to the Isadora.
Thank you for the question and for all the discussion. Actually, I can hear a lot of the common challenges actually from Faricia and Paul and Leonardo. But when it comes to China, if you ask me what is the biggest challenge for China to decarbonize its chemical sector, I would say just transition of coal is the biggest challenge, because there are 4 biggest coal-producing provinces in China, which produces about 90% of China's total coal production, and they rely heavily. Their economy rely heavily on the coal industry, whether it's coal mining or coal processing or coal power. So like right now we do have like Agora China do have another work stream focusing on regional coal transition, and we can always tell that it's very hard for those local businesses to find new growth points or new investment opportunities. Although many of the coal chemical companies like Meijin and Inner Mongolia companies, they are actively looking for the combination of renewables and coal chemicals, but many of their success cases are not replicable. So there's no kind of a common pathway that others could just copy and paste. So it's quite challenging. And also at the federal, like the central government level in China, like the Chinese government does not really like it. I would say it's a little bit reluctant to phase out coal totally, especially after last year we have some power crunches. They are determined that we have to keep coal because we want to have energy security or supply security within the country instead of like like relying on oil import or gas import. So this urge to maintain the coal chemical sector in China is quite strong actually. All we could do is to first curb its its development and growth, make it like the current scale, and then by time we can try to descale it. Yeah.
Oh, thank you for the answer. But it's a very interesting thing that is normally the core just transition for the core workers, core employees, core industry employee is just happened in the power industry, but China is a very special case to connect the core just transition to the chemical industry is very interesting perspective. Okay. Lastly, I would like to same question to the Boram Kim.
Thank you. And I agree with what's been mentioned in the discussion already, technology cooperation roadmap, just transition, and so on. And just to add in the discussion, I would like to mention just a couple, 2-3 things. And in terms of the business side of things, I think one of the big barriers is acquiring sustainable feedstock. And ultimately, we will have to import green hydrogen and green ammonia. So having that infrastructure through international cooperation at a competitive price will also be very important. And I think second would be having a standardized framework, as mentioned, governing and assessing embodied carbon content. So unlike, I think, Germany, the presentation also mentioned about CBAM, but as a very export-oriented country, our main exporting countries are not really, in terms of chemical industries, are not European countries. So it would be nice to have that kind of standard expanded worldwide, and which would really incentivize the chemical industry that is kind of happening for steel industry. And I think third would be obviously to reduce unnecessarily demand. I think it's important to question whether this current pattern of consumption is really sustainable. So not just plastics, but as I mentioned before, like Korea is highly integrated with refinery industry to produce transportation fuels. So energy transition within the transportation sector in other countries would, I think, be highly influential in terms of decarbonizing Korean chemical industry. So I think everything's very intertwined, and we hope to work together and continue this kind of discussion in the future. Thank you.
Thank you, Boram. I understand and I agree with your opinion and your answers. We already talked about this issue very deeply. So then the next session is getting the question from the audience. Then I have 2 questions from the audience. The first question is that, do you have any lessons learned for financial instrument to scale up green hydrogen in hard to abate industry? Okay, I hope you remember. And the second question is that, how can think tank like us contribute to decarbonization of the chemical industry? Okay, I will not specify one panel, but if you have some volunteers to answer this question, and just raise your hand. Okay. Then otherwise, then okay. Thank you, Paul.
Yes, happy to touch upon this. So scaling up green hydrogen in hard to abate industries, I think, is something where I can say something about, since we've been working on that issue for most of the time since Agora Industry is working. So I think there are several elements, and one of it is definitely the carbon contracts for difference. I think Isa already mentioned them in her presentation. And carbon contracts for difference basically are a policy instrument that covers the cost premium for a climate-friendly production. So if you compare steel, for example, where the production value chain is more simple, you have, first of all, the iron production where you use coal or hydrogen to produce iron from iron ore. And if you want to switch now from coal to hydrogen, this comes with a high cost premium. So that makes steel more expensive if it's produced in a climate-friendly way. And there we have developed a policy instrument, the carbon contracts for difference, which would cover this cost premium for a certain amount of time to enable the companies to build up this new technology. And how is it related to hydrogen? So we believe that these sectors are also a great starting point for building up a hydrogen infrastructure. So by assuring the ramping up of hydrogen, the ramping up of this demand for hydrogen, it also allows for building up and deploying the infrastructure that we need for renewable hydrogen.
Thank you, Paul. And then we, from the audience, we have a more question. I think the question is specified specified by the audience. Okay, the Paul already answered the question, and then I would like to specify the question. And from the audience, the question is that tell us more on IESR recent research of the Indonesia 5 biggest carbon emitter and their relationship with the recently announced carbon exchange in Indonesia. And then Isadora have some audience ask question. What are the expected impact of the new EU CBAM scheme to China export products to EU? Okay, there's time is limited, and then just let's hear 2 questions first.
Okay, so actually I have already answered that on the Q&A box, but I would like to extend maybe a little bit of explanation for that. So actually our work, as I mentioned before, focuses on the 5 heavy emitters. It's like cement and iron, steel, and then ammonia, textile, and pulp and paper. And all of these we use the similar approach. So we mapping out the decarbonization pillars and what are the carbon emission reduction potential that it will be generated from implementing all of those decarbonization pillars. And regarding for the carbon market exchange that the government of Indonesia just already launched, maybe on last September. So currently the implementation of it is still very limited, and not every industry is already being involved in the carbon market exchange. And but hopefully there is currently undergoing the study on the carbon trading for the industry sector from the Ministry of Industry. And by using our roadmap, it will give the foundation for them to determine the carbon cap value for each of the industry. Of course, this has to be expand a little bit more, but we expect that our work will give the policymakers the foundation of building more robust carbon market in industry sector in Indonesia. Thank you. I hope that answers the question.
Thank you, Lesia. And then Isadora. And
thank you for the moderator and also for asking the question. And I actually also put in my answer, but I can happy to elaborate more about the answer. CBAM right now does not have a big influence on China's chemical sector exports yet, because now it's only covering the fertilizer and its upstream raw materials, and China exports mainly nitrogen fertilizers to the EU. And because in the past, like I said, last year, we observed a very sharp increase both in amount and in values because of the Russian war in Ukraine. But this trend is not expected to continue. So we wouldn't expect to see a big influence, and we didn't hear a lot of concern from Chinese chemical sector industry. But if by in 2030 the EU ETS, the EU CBAM expands to organic chemicals and also plastics, then the impact will be much bigger on China, because China, like under the EU CBAM and EU ETS scheme, China exports about 11 different products of plastics to the EU, and under each of them, the export value exceeds 30 million euros. So once that's being covered by the EU CBAM, the plastic sector in China will panic and will do a lot of efforts to try to decarbonize their products. But right now they are already working on it.
Okay, thank you for the answer, Isadora. I think Korea is the same situation. It's a chemical, CBAM regarding the chemical is not that happened yet. So many chemical industry think that it is very far from the future. And so then I would like to ask a question about the think tank's role for the decarbonization of the chemical industry. So I would like to ask this question to the Boram.
Thank you for the question. And I think it's very important that think tanks are involved in this discussion, although there's been some limited discussion due to complexity, and also we had more important priorities within the energy sector and so on. But because our research are very independent, so there's unlike corporate institutes or government institutes, we don't really have government agenda or business agenda attached to our researchers. So I think we can provide a very neutral and very concrete analysis in terms of achieving carbon neutrality. And I think as civil societies, we are also very involved in communicating with wide range of stakeholders. So industries, corporates, politicians, and university academics, and also other think tanks, international think tanks, as we have here today, which I am very grateful. I think we through these discussions, we are able to propose policy recommendation that's very practical and also very leading discussions that's not been discussed enough within the current Korean or international dialogue. So I think it's very important. Thank you.
Okay, I think that this question is, I think it's fair to ask this question to every panel. So I think the Isadora can answer or can add some discussion on this question.
Sure. I would like to second what Forum has just mentioned. Actually, as think tank, we could provide independent and neutral research findings and help the government better in making their policies. And actually, this is very, very valuable in China under the current context, because there are many government affiliated think tanks too in China, and they are because their position is they're kind of funded by the government, they are very reluctant to say something that is opposite to the government's position, then which limits their role actually. And as an international think tank and based in China, we feel free to contradict their research findings and say something voice different opinions, which is very important in China. And many of the think tanks like international think tanks are also deeply involved in making the like carbon peaking roadmap or sector decarbonization plans together with the industry sector and with enterprises. So these are all very good developments. And also, I would like to also mention about international collaboration, because these will provide a bigger picture of, what the world is leading toward, and also what others are doing. We always say that what experiences we could learn from the European Union, from other countries, and also what other like pitfalls we could try to avoid, and what lessons learned could be, be of some kind of alarm for us, and to cut our cost in our decarbonization. So international collaboration and also think tanks' role, I think, are essential in China.
Yeah, I totally agree with you. And then I think this kind of webinar should be more frequently happen, and then to more engaging, and then to share some our knowledge, our status of the industry decarbonization for the future. And then Felicia, can you answer the role of the think tank for the decarbonization of the chemical industry?
Okay, so I believe already the answers already maybe almost the same with the all of the panelists here, but maybe I would like to add one more point of view. So actually, because like think tank is independent, and always the policy recommendation always based on the data driven or research result. So it will help it will help the policy makers to make a great decision making. And the second one is to because usually think tanks have great capability to build engagement and communication with other important actors such as industries and communities, local communities. So it will help raise awareness to them and help accelerate the carbon neutrality in even faster. Thank you.
Thank you, Felicia. And so we have 2 minutes, and then Paul, can you add some discussion for this question?
Yeah, happy to. I don't want to repeat what the others already said, but I absolutely agree. But I would add maybe 2 points. First of all, I believe that especially think tanks in the field of industry decarbonization or industry transformation are absolutely crucial at the moment, since there is, to my observation is that there is just not enough understanding on what is going on. I mean, when discussing climate change mitigation, we talk about renewable energies, and that is absolutely correct. But seeing the deployment of renewables and how little is happening in industry, we will end up in a situation where we'll have a clean power sector, but have huge emissions in the industry sector. So I think the sector deserves much more attention, and I think our work as think tanks working on industrial transformation plays a big role in drawing that attention. And the second point is regarding the chemical industry. I believe that especially the chemical industry, with all its international value chains, with the different processes which feed into one another, has a very, very high complexity. And if you want to develop policy instruments, that gives a lot of difficulty to policymakers. So I think it is very important to have more people working on the transformation of chemicals, more people on understanding more what is actually needed from a technical perspective to derive good policy recommendations from that. So I encourage everyone, I hope we all stay in touch, and everyone else who's listening, please join us in greening the chemical industry internationally.
Yes, you're right. We need more people and more human resources to make this the subject more vocal to each government. And then it's a time to wrap up, and I think that it's time to hand in my mic to the Lydia.
Thank you very much, Pilsok, for leading the second part of the event and the introduction in the beginning. And thank you very much to all our speakers and the audience for your attention and the questions on the greening of chemical industry. I have seen quite some movement in the Q&A box. We just had a very interactive, interesting Q&A session. And I really enjoyed learning about the various circumstances and solutions for these processes, but also finding out the commonalities and ways to make the international cooperation more relevant for national context. And this is what I think the think tanks are skilled to do best, as we just heard in the last exchange. And I hope you enjoyed the event as much as I did and learned new perspectives. As our webinar is coming to an end, I would like to remind you that all presentations are already available on GESI's website. Please see the link in the chat box that was kindly delivered to us by Hyunji, who is in the background. Thank you, Hyunji, for all the help and support. It was really good to have you with us and make sure that everything is being taken care of. The recording of this session, if you want to come back to it, will be available on GESI's YouTube channel shortly. And in case you still have questions now or in the future, please feel free to provide them to GESI on the email address, which will be posted in the chat box, as well to contact the presenters. Each presentation had actually reminder who the speaker is and how to contact them. And with that, I would like to say goodbye and wish you a very good evening or evening, depending where you've been watching this webinar from. Thank you very much and goodbye.